Good evening, ma'am.
Good evening, sir. You can start now, sir.
Yes, ma'am. 1 minute, 1 minute. Now, yesterday's class, we learned about Dalton's theory of an atom, and we worked some of the problems also, and we have learned the merits and demerits of Dalton's theory of an atom. Now, in this basic concept, we need to learn or define what is an atom, what is a molecule, what is the atomic mass, all that. Now, the first term to be understood is atom. What is an atom? It is the smallest particle of an element that takes part in the chemical bonding, but they cannot generally exist freely as such, is called as an atom. Atom cannot exist freely. It is the smallest particle which can take part in a chemical bond. That is called as an atom. Now, for an example, if we take oxygen molecule, this oxygen molecule is made of oxygen atoms. This oxygen atom cannot exist freely. But when they combine with another oxygen, then a molecule is formed. And this oxygen molecule can exist freely, or they can exist independently. So this O2 will be called as a molecule, and oxygen, O, will be called as an atom. So atom is the smallest particle of an element. We learned what is an element, we learned what is a molecule, we learned what is a compound, all that we learned in previous classes. So atom is the smallest particle of an element which involves in chemical bonding, but generally they cannot exist freely. I just give you an example. Similarly, if you take hydrogen molecule, H2 is a molecule. They can exist freely, but this hydrogen atoms cannot exist freely. These are atoms. So they combine to form a molecule. So that is why we define atom to be the smallest particle of an element which take part or which involves in chemical bonding, and they cannot exist freely. Now, the second term we need to understand is called as a molecule. The smallest particle of a substance, any substance is made up of molecules. Now, the substance can be element or a compound, which has independent existence, is called as a molecule. So now, for an example, O2 is a molecule, and H2O is also a molecule. But O2 can be called as an element because this O2 is made of similar atoms, oxygen atoms. Therefore, this also can be called as an element. But water, H2O, we cannot call it as an element. We call it as a compound. We call it as a compound. So molecules are smallest particle of a substance, either of the element or of the compound, which has independent existence. So molecule can exist independently. Now we have to learn atomic mass, molecular mass, all that. Now, what's the definition of an atomic mass? How do we define atomic mass? So atomic mass is defined as the number which indicates how many times mass of one atom of the element is heavier than 1/12 the mass of carbon-12 isotope, or carbon-12 mass of an atom of carbon-12 is known as atomic mass unit. Now, atomic mass can be just defined as mass of an atom. So when we say mass of an atom, so we define atomic mass as the ratio of mass of an atom to 1/12 the mass of 1/12 the mass of carbon-12 isotope. Now, why we are taking carbon-12 isotope? In earlier days, they were talking about hydrogen as a standard, but the atomic mass of hydrogen is 1.008. It is not 1. And later, we understood oxygen to be a standard, and it is not 16.0, it is 16 point a fraction. But when we take carbon-12 isotope, the atomic mass of carbon-12 is exactly 12. Therefore, carbon-12 is taken as a standard. Now, atomic mass is defined as the ratio of mass of an atom to 1/12 the mass of carbon-12 isotope. When we say 1/12 the mass of carbon-12 isotope, 1/12 the mass of carbon-12, the mass of carbon-12 is 12. It's again 1. It's again. So that means atomic mass is just the mass of an atom will be called as atomic mass. Now, we express or we represent that in terms of atomic mass units. So atomic mass is defined as the number which indicates how many times the mass of one atom of an element are heavier than 1/12 the mass of carbon-12 isotope, or carbon-12 mass of an atom of carbon-12. And that is known as atomic mass unit. Now, we understand, or you remember, atomic mass is defined as the ratio of mass of an atom to 1/12 the mass of carbon-12 isotope. And 1 AM, it is equal to 1.6 into 10 to the power minus 24 grams. 1.66 into 10 power minus 24 grams. So atomic weight of an element in the early, as I told you, in earlier days, hydrogen was considered to be what? The standard. Weight of one atom of an element divided by weight of one atom of hydrogen. In the classical way, in the olden days, so it is defined, atomic weight is defined as, atomic weight or atomic mass is defined as weight of one atom of element divided by weight of one atom of hydrogen. When the equivalent weight scale was altered from hydrogen 1 to oxygen 16, the definition of atomic weight changes to weight of one atom of the element to 1/16 the weight of one atom of oxygen. Again, we understand that oxygen atomic mass is not exactly 16, I told you. So in modern reference, standard for atomic weight is carbon isotope. Now, carbon-12 isotope, because the atomic mass of carbon-12 isotope is exactly 12. So atomic weight of an element is defined as the ratio of mass of one atom of an element, or weight of one atom of an element, to 1/12 the weight of carbon-12 isotope. 1/12 the weight of carbon-12 isotope is almost nothing but 1. Therefore, atomic weight of an element is nothing but weight of an atom. Now, units of atomic weight. The modern unit of atomic weight is 1/12 the mass of one atom of carbon. Unit of atomic weight representation as AMU. So, unit of atomic weight, the modern unit of atomic weight is 1/12 the mass of one atom of carbon. And it's represented in terms of AMU, atomic mass unit. 1 AMU is equal to 1/12 the mass of carbon-12 isotope or carbon-12 atom. Mass of one atom of carbon-12 has been determined as 1.9924 10 per 23 grams. Therefore, 1 AMU is equal to 1.9924 10 per minus 23 divided by 23. Therefore, that will be equal to 1.66 into 10 power minus 12 minus 24 grams. So 1.66 into 10 power 24 grams referred as gram equivalent of atomic mass units. So 1 AMU, this relation you have to understand. 1 AMU is equal to 1/12 the mass of carbon-12 isotope. What is the mass of carbon-12 isotope? It should be 12. It is not 23. It should be 12. So what is the mass of carbon-12 isotope? Mass of one atom of carbon-12 isotope is 1.9924 into 10 power 23 grams. So 1.9924 in 10 power minus 23 grams but divided by 12 will give you 1.66 in 10 power minus 24. So 1.66 into minus 24 gram is referred as equivalent gram equivalent of atomic mass unit. Just give me one moment. Yeah, so this is correct. So it is not 23, it is 20, it is 12. See, the formula is here. 1 AMU is equal to 1/12 the mass of carbon-12 isotope. Now, how do we find the mass of a single atom? We will learn about it in the following classes. Atomic mass of an element expressed in gram is called as gram atomic mass. It is also called as gram atom. Example, the atomic mass of oxygen is 16 atomic mass units, or the gram atomic mass of oxygen is 16. So whenever the atomic mass is expressed in grams, it is called as gram atomic mass. So atomic mass is expressed in terms of grams. So therefore, it's called as gram atomic mass. Average atomic mass. Now, elements are found in different isotopic forms. Elements are found in different isotopic forms. Now, for an example, we take carbon, atomic mass of carbon is 12, and atomic number is 6. The next isotope is 13 and 6, so 14 and 6. So carbon exists in 3 isotopes. Atomic mass will vary, atomic number remains the same. So what is the average atomic mass? So average atomic mass can be found out using the formula mentioned here. We will learn about it. Elements are found in different isotopic forms. Atoms of same elements having different atomic mass are called as isotopes. So these are the 3 isotopes of carbon. Carbon-12, carbon-13, and carbon-14. Carbon-14 is radioactive. So atomic mass will differ, but atomic number remains the same. So the atomic mass of an element is the average of isotopic mass within a given sample. Isotopic mass within a given sample. Now you can see the formula. Average atomic mass is calculated by the formula mass of first isotope into its percentage plus mass of second isotope into its percentage divided by percentage of first isotope plus percentage of second isotope. Now, for an example, if we say carbon-12, in nature it exists 75%, and carbon-13, if it exists 25%, if we say it is not true, so it will be mass of first isotope, which is carbon-12, 12 plus 75. 12 into 75 plus 13, carbon-13, and the percentage is 25 divided by 75 plus 25. So this simplification will give you the average mass of carbon. We will work out the problems later. This is not the right percentages. So average atomic mass is given by the ratio of mass of first isotope into its percentage plus mass of second isotope into its percentage divided by percentage of first isotope plus percentage of second isotope. If you have 3 isotopes, mass of first isotope into its percentage plus mass of second isotope into its percentage plus mass of third isotope into its percentage divided by percentage of first isotope plus percentage of second isotope plus percentage of third isotope. It goes on. So average atomic mass is because elements are found in different isotopic forms. What are isotopes? Atoms having same atomic number but different atomic mass are called as isotopes. Now use the data given in the following table, calculate the molecular mass of naturally occurring organ. So naturally occurring organ. So they've given the percentage. So argon 36, argon 38, argon 40. Isotope mass they have given, and they have given you the abundance. So in the next slide, they would have given. So we learn average mass, average atomic mass is represented or is calculated by the formula mass of first isotope into percentage plus mass of second isotope into percentage plus mass of third isotope into percentage divided by percentage of first isotope plus percentage of second isotope plus percentage of third isotope. So mass of first isotope, what is that they've given? The mass of first isotope. It's 35.96755 and 7.1 is the abundance. So 35.96755 and percentage, instead of instead of dividing it like this, they've taken it as percent divided by 100. We will take it as 7.1 itself. Plus second isotope, it is 37.96272. Percentage is 16.3, 16.3 plus of the third isotope is 39.96924 into percentage, what they've given, abundance or percentage they've given as 76.6 divided by 7.1 plus 16.3 plus 76.6. So on calculation, on simplification, we will get the answer to be 39.352 gram per mole. So the average atomic mass of argon is 39.352. This becomes 100. The denominator total percentage becomes 100. So when you simplify, the answer we get is 39.352 gram per. The second example, carbon occurs in nature as a mixture of carbon-12 and carbon-13. Carbon-12 and carbon-13. The average atomic mass of carbon is 12.011. Average atomic mass. What is the percentage abundance of carbon-12 in nature? So they have asked the percentage of carbon-12 in nature. So they've given the average atomic mass. They're asking you to calculate the abundance of carbon-12. Now, if we take carbon-12, carbon-12 is 12. It's not like this. So carbon-12, if we take it as X%, then carbon-13 exists as 100 minus X. The percentage of carbon-13 will be 100 minus X. So if you calculate the average atomic mass of carbon, they're given as 12.011. That is equal to 12 into X. Atomic mass of carbon is 12. Percentage of carbon is X plus 13 into percentage of carbon-13, as we found out here, it's 100 minus X divided by total percentage. Total percentage is X plus 100 minus X. This is nothing but 100. If you solve for X, the percentage what we get is 98.9%. Solve for X. This becomes what? 100. So when you solve for X, the answer is 98.9%. The next is molecular mass. So molecular mass also has a definition same as the atomic mass. Molecular mass is defined as the ratio of weight of one molecule of a substance divided by 1/12 the weight of carbon-12 isotope. So molecular mass is defined as is a number which indicates how many times the mass of one molecule of a substance is heavier than 1/12 the carbon-12 isotope. So molecular mass is the number which indicates how many times the mass of one molecule of a substance is heavier than carbon-12 isotope. Now, molecular weight is defined as the ratio of weight of one molecule of a substance divided by 1/12 the mass weight of one atom of carbon-12 isotope. Molecular weight of a substance is an additive property. It can be calculated by adding the atomic weights of atoms present in one molecule by multiplying the atomic mass of each element by the number of its atom and adding them together. So this statement looks complex. We will try to make it simple. Now, for an example, if you take a molecule, NaOH, this is a molecule. Its molecular weight is sum of the atomic weights of all atoms. So atomic mass of sodium is 23, atomic mass of oxygen is 16, atomic mass of hydrogen is 1. So sum of this is giving you the molecular mass. So molecular mass of sodium hydroxide is 40. Now, if you take another example, if you take carbon dioxide, the molecular mass is carbon atomic mass is 12, atomic mass of oxygen is 16. Since we have 2, we have to multiply it by 2. So therefore, it will be 12 plus 32, it will be 44 grams. So the statement now, if you read, you will understand. Molecular weight of a substance is an additive property. It can be calculated by adding the atomic weights of atom present in a molecule. Atomic weight of atom present in one molecule. See, the atoms present in sodium hydroxide is sodium, oxygen, and hydrogen. Atomic mass of sodium, oxygen, and hydrogen gives you the molecular mass of sodium hydroxide. And the statement here is by multiplying the atomic mass of each element by the number of its atoms. Here, sodium is 1, oxygen is 1, hydrogen is 1. So therefore, if we multiply by 1, it makes no difference. But in case of this example, 2 oxygen atoms are there. So atomic mass of oxygen has to be multiplied by 2. So when you multiply by 2 and add with the atomic mass of carbon, we get 44. So 44 is the molecular mass of carbon dioxide. Now, as example, molecular mass of methane. Molecular mass of methane, carbon is 12 atomic mass, and they're given atomic mass here, 12.008. And since we have 4 hydrogen, we have to multiply it by 4 and then add it. So 16.043. More accurate molecular mass of methane is 16.043. Similarly for water. Water, if you take H2O, we have 2 hydrogen atoms. 2 into atomic mass of hydrogen is 1.008. Plus of oxygen atomic mass is 16. Therefore, the answer you'll get is around 18.016 that I have mentioned. Similarly for calcium carbonate. Calcium atomic mass is 40. Carbon atomic mass is 12. 12.011, or we take it nearest whole number is 12. Plus oxygen atomic mass is 16. And since we have 3 oxygen atoms multiplied by 3, so 40 plus 12 plus 16, 3 is 48. It will be equal to 100. So the molecular mass of calcium carbonate is 100. So molecular mass is an additive property. It is the sum of the atomic masses of different atoms present in a molecule. If you have a same atom, many number of times, you have to multiply by that many number of times and add. Gram molecular mass. The molecular mass of an element or compound expressed in grams is called as gram molecular mass. Now, oxygen, if you take, it is O2. The molecular mass, when we express in atomic mass unit, it is 32 atomic mass. The same molecular mass, if we express it in terms of grams, it's called as gram molecular mass. It's called as gram molecular mass. So molecular mass is nothing but molecular weight expressed in terms of grams is called as gram molecular mass. So 1 gram molecular mass of oxygen is 32 grams. What do you mean by 1 gram molecular mass? Molecular weight of one molecule is called as 1 gram molecular mass, which is expressed in terms of grams. So therefore, it is 32 grams of oxygen. Now, calculation of molecular mass. It's given, we will learn sulfuric acid is H2SO4. Now, we have to calculate the molecular mass. We told molecular mass is an additive property. Now, 2 hydrogen we have, and the atomic mass of hydrogen is 1. So I write 2 into 1 plus of sulfur, I have 1, and atomic mass of sulfur is 32. Atomic mass of sulfur is 32 plus oxygen we have 4, atomic mass of oxygen is 16. So it will be 2 into 1 is 2 plus 1 into 32 is 32 plus 16 into 4 is 64. So if we add together, we will get 98. So the molecular mass of sulfuric acid is 98. The second example, they've given glucose. The glucose has molecular formula C6H12O6. Now 6 carbon atom we have, and the atomic mass of carbon is 12. So 6 into 12 plus 12 hydrogen we have, atomic mass of hydrogen is 1. Plus we have 6 oxygen, atomic mass of oxygen is 60. So 6 12s are 72. Plus 12 into 1 is 12 plus 60 into 6 is 96. So when we add these, it is 180. So 180 is the molecular mass of glucose. If we express it as grams, then this becomes gram molecular mass. Likewise, they have given for the third example given is oxalic acid, hydrated salt, H2C2O4.2H2O. It's a salt. Oxalic acid is a crystal. Now we have totally 2, 3, 4, 5, 6, 6 hydrogen. 6 into 1 plus 2 carbon, 2 into 12, atomic mass of carbon is 12, plus we have 4 and 2, 6 oxygen. So atomic mass of oxygen is 16, 6 into 16. 6 plus 24 plus 96. So on addition, we will get the molecular mass of oxalic acid to be 126. So sum of atomic masses of individual molecule will give you molecular mass. Molar volume, we learned it. In the previous classes, we learned. Now, the molecular weight of hydrogen is 2 grams. Similarly, molecular weight of oxygen is 32 grams. Oxygen is 16, 16 into 2 is 32. Now, 2 grams, if we blow 2 grams of hydrogen, if you blow it into a balloon, the balloon gets blown. The first case, case 1. This case 2, if we blow 32 grams of oxygen in a balloon, that also gets blown. Now, this also balloon gets blown, and here also the balloon gets blown. Now, if you measure the volume of the balloon, if you measure the volume occupied by the balloon at STP, STP is standard temperature and pressure, and 1 atmospheric pressure and 273 Kelvin. So the volume will be 22.4 liters. Here also the volume of the balloon occupied will be 22.4 liters. So molar volume is defined as volume occupied by 1 mole of a gas at STP is called as molar volume. How do we define molar volume? So volume occupied by a gas, volume occupied by 1 mole of a gas at STP is called as molar volume. So 2 grams of hydrogen will be called as 1 mole because 2 grams of hydrogen contains Avogadro's number of hydrogen molecules. Likewise, 32 grams of hydrogen also will be considered as 1 mole because 32 grams of hydrogen also contain Avogadro's number of, 32 grams of oxygen also contains Avogadro's number of oxygen molecules. So therefore, 32 grams of oxygen will be called as 1 mole. So 1 mole of hydrogen gas, 1 mole of oxygen gas occupies 22.4 liters. Therefore, this 22.4 liter is the volume of, it's called as molar volume. So volume of 1 mole of gas at STP is 22.4 liter. This is called as molar volume. So it's not only with respect to hydrogen and oxygen, it can be for any gas. Now, for an example, if you take carbon dioxide gas, 44 grams. If you take nitrogen gas, it is 28 grams. So 44 grams of nitrogen also occupies 22.4 liter at STP. 28 grams of nitrogen also occupies 22.4 liter at STP. Therefore, this we conclude it as molar volume. Volume occupied by 1 mole of a gas at STP is called as molar volume. equivalent mass. Now we should understand that elements do not combine based on their mass. Now it means, now I cannot say, if I take I cannot say 10 grams of hydrogen combines with 10 grams of oxygen. It is not possible. So elements do not combine based on the mass. Elements combine based on their equivalent mass. Elements combine based on their equivalent mass. So we have to understand the term called as equivalent weight now, or equivalent mass. What is this equivalent mass or equivalent weight? So equivalent mass or equivalent weight is defined as the number of parts by mass of a substance that combines with or displaces 1.008 part by mass of hydrogen, or 8 part of oxygen, or 35.5 part of chlorine is called as equivalent mass. On the other hand, quantity of substance in grams numerically equal to its equivalent mass is called as gram equivalent mass. GEEM stands for gram equivalent mass or gram equivalent. Now, the first part of the definition we will try to understand. The number of parts by mass of a substance that combine with or displaces 1.008 part of hydrogen, or 8 part of oxygen, or 35.5 part of chlorine is called as equivalent mass. Now we will take a simple example and try to understand the definition of equivalent mass. If you take water, we know that the atomic mass of hydrogen is 1.008. So since we have 2 hydrogen, it's 1.00 into 2 plus atomic mass of oxygen is 16. Therefore, we get 18.00016. This is the molecular mass of water. Molecular mass of water. Now we are not talking about the molecular mass, we're talking about equivalent mass. Now, from this molecular formula H2O, we understand 2.016 grams of hydrogen combines with 16 grams of oxygen. The statement here clearly says number of parts by mass of a substance that combines with or displaces 1.008. Here, 16 grams of oxygen combines with 2 grams of hydrogen. So if that is the case, 1.008 gram of hydrogen will combine with how many grams of oxygen? It is 1.008 into 16 divided by 2, it will be 8. That means 1.008 gram of hydrogen is equivalent to 8 grams of oxygen. Therefore, we say the equivalent mass of oxygen is 8. We will take a few more examples and we will try to understand here. Now, the second example is HCl. Now, 1.008 grams of HCl combines with 35.5 grams of chlorine. Therefore, we say 1.008 gram of hydrogen is equivalent to 35.5 gram of chlorine. So equivalent weight of chlorine is 35.5. So the definition goes like this. Number of parts by mass of a substance that combine with or displaces. We will learn about the displacement in a few minutes' time. Combines with 1.008 part of hydrogen, or 8 part of oxygen, or 35.5 part of chlorine, or 23 part of sodium, or we can go on telling about all the elements in the periodic table. Now, for displacement, how we understand. Magnesium, when allowed to react with hydrochloric acid. Magnesium, when we allow it to react with hydrochloric acid, we get magnesium chloride, giving you hydrogen gas. This is the reaction. Now, magnesium being more reactive, it will displace hydrogen. It is called as a displacement reaction. Now, 24 grams of magnesium, because the molecular atomic mass of magnesium is 24. 24 grams of magnesium gives 2.016 gram of hydrogen. Therefore, if 1.008 gram of hydrogen, if it has to give, what is the mass? It will be 24 into 1.008 divided by 2.016. That will be equal to 12. So the equivalent weight of magnesium is 12. It is not 24 because 24 grams of magnesium gives 2 grams of hydrogen. 24 grams of magnesium is equivalent to 2.016 gram of hydrogen. But equivalent mass is not based on that. It should be based on 1.008 gram of hydrogen. So therefore, it will be 12. So 12 grams of magnesium is equivalent to 1.008 gram of hydrogen. Now, coming to the expression of for equivalent mass. So expression, how do we calculate the equivalent mass? So equivalent mass can be calculated, or equivalent mass of an element is calculated by the formula atomic mass by valency. Second, equivalent mass of an acid is calculated by molecular mass by basicity. And the basicity of acid is the number of replaceable hydrogen atom in one molecule of acid. And then we have equivalent mass of a base, molecular mass by acidity. And we will learn one by one. Now I'll erase this part and then I will teach you. Now, equivalent mass is calculated by various compounds. It's calculated in different formula. Now, elements, equivalent mass of an element is calculated by the formula atomic mass by valency. Now, we understand valency is nothing but the combining capacity of an element. Valency is defined as the combining capacity of an element. What is the equivalent mass of sodium? We'll try to calculate the equivalent weight of sodium or equivalent mass of sodium. Atomic mass of sodium is 23. What is the valency of sodium? We know that the valency of sodium is 1. The combining capacity of sodium is 1. For an example, if you take sodium chloride, the sodium can combine only with one chlorine atom. Therefore, the valency is 1. So divided by 1. So it will be 23. So for sodium, equivalent mass and atomic mass remains the same. Now, similarly, what will be the equivalent mass of magnesium? Magnesium atomic mass is 24. Valency of magnesium, if you remember, we learned, I erased it. We learned magnesium chloride formula to be MgCl2. That means one magnesium atom combines with 2 chlorine. One magnesium atom combines with 2 chlorine. Therefore, the valency of magnesium is 2. Therefore, 24 divided by 2. So it will be 12. Equivalent mass of magnesium is 12. Likewise, if we take equivalent mass, try to calculate equivalent mass of aluminum. Aluminum atomic number is 27. And aluminum chloride as a molecular formula, for an example, it is 3. That means one atom of aluminum combines with 3 chlorine atoms. Therefore, the valency of aluminum is 3. So 27 by 3. So equivalent mass for aluminum is 9. So here the sodium, magnesium, aluminum, what we spoke, all those are elements. So for an element, how do we find the equivalent mass? For an element, equivalent mass is determined by the formula atomic mass by valency. So atomic mass by valency. Now, equivalent mass of an acid. We'll learn the calculation of equivalent mass of an acid. Before that, we should learn the term called as basicity. When we talk about acid, we need to talk about the term called as basicity. Now, what is this basicity? Now, for an example, if we take HCl, now this HCl, when allowed to react with sodium hydroxide, the sodium being more reactive will displace hydrogen. So we will get NaCl and water. It's a neutralization reaction. So in HCl, we have only one replaceable hydrogen. Therefore, the basicity of HCl is 1. So basicity is defined as number of replaceable hydrogen present in one molecule of an acid. Now, if you take a second acid, H2SO4, this H2SO4, when it's allowed to react with sodium hydroxide, this 2 sodium atom will displace hydrogen. So we get sodium sulfate plus we get 2 moles of water. Since it has 2 replaceable hydrogen, we call the basicity of sulfuric acid is 2. Likewise, if you take oxalic acid, H2C2O4, this oxalic acid is also having basicity 2 because these 2 replaceable hydrogen. Oxalic acid molecular formula we wrote like this, H2C2O4 dot 2H2. These hydrogens are not replaceable. Only these 2 hydrogens are replaceable. Therefore, the basicity of oxalic acid is 2. If you take phosphoric acid, H3PO4, this has 3 replaceable hydrogens. So basicity of phosphoric acid is 3. So based on this, we will try to calculate the molecular mass of equivalent mass of few of the acids. Now, what is the equivalent mass of hydrochloric acid? How do we calculate the equivalent mass of hydrochloric acid? Equivalent weight of hydrochloric acid or equivalent mass of hydrochloric. So molecular mass of hydrochloric acid. Hydrogen is 1 and chlorine is 35.5. So therefore, the molecular mass is 36.5. 36.5. And the basicity of hydrochloric acid will be 1. Therefore, it is 36. The basicity is 1. We call those as monobasic acid. It's called as monobasic acid. When basicity is 1, we call that as monobasic acid. For a monobasic acid, molecular mass and equivalent mass remains same. Molecular weight and equivalent weight remains same. Now, the second example, HNO3 nitric acid. Nitric acid, the molecular mass is 1 plus 14 plus 48. So it will be 63. So what will be the equivalent weight of nitric acid? Equivalent weight of nitric acid is also 63 divided by 1 because we have only one replaceable hydrogen. So we have only one replaceable hydrogen. The equivalent and molecular mass of nitric acid will remain same. But this is also an example for monobasic acid. Nitric acid is also an example for monobasic acid. When we talk about sulfuric acid, H2SO4, the molecular weight of sulfuric acid is 2, hydrogens 1 into 2 is 2, sulfur is 32, oxygen is 4 into 16. So if you simplify, it's 98. Since the basicity of sulfuric acid is 2, the equivalent weight of sulfuric acid will be 98 divided by 2, it will be 49. So 98 is the molecular mass and the equivalent mass of sulfuric acid is 49. Sulfuric acid is a dibasic acid. Why it is a dibasic acid? Because it has 2 replaceable hydrogen. Therefore, it is a dibasic acid. So phosphoric acid, H3PO4, we have 3 replaceable hydrogen. Therefore, basicity is 3. It is called as tribasic acid. Tribasic acid also will have the equivalent mass will be for phosphoric acid, equivalent mass will be given by the formula molecular mass by 3. Coming to the equivalent mass of a base. Equivalent mass of a base is given by the formula molecular mass by acidity. Acidity is acidity of a base. When we talk about a base, we need to talk about acidity. Acidity of a base is the number of replaceable OH groups. Now, for an example, if you take NaOH, in this NaOH is allowed to react with HCl. This Cl will displace OH. So we get NaCl and H and OH gets eliminated as water. So we have one replaceable hydrogen. Therefore, acidity of NaOH is 1. When acidity of NaOH is 1, what is the equivalent mass of NaOH? So molecular weight of NaOH is 40, 23 plus 16 plus 1. And acidity is 1, therefore it's again 40. For monoacidic base, equivalent mass and molecular mass remain same. Now, for an example, if you take calcium hydroxide. Now, this calcium hydroxide, when we allow it to react with HCl, we get calcium chloride and 2H2. 2H2O. So it contains 2 replaceable hydrogen. So acidity of calcium hydroxide is 2. Therefore, the equivalent weight will be molecular mass divided by 2. Molecular mass is 40 plus oxygen is 60 into 2 is 32 plus hydrogen is 2. So it will be 74. So 74 divided by 2. So the equivalent mass of calcium hydroxide is 37. Equivalent mass of calcium hydroxide is 37. So whenever we talk about a base, we need to talk about acidity. So acidity is defined as the number of replaceable OH groups in one molecule of the base. There are certain bases which contains no OH group. Now, for an example, ammonia is a very well-known base. It does not contain OH group. Then how do we calculate the equivalent mass of this? So we'll be learning all that in the next class. So coming to the equivalent mass of salt, equivalent mass of oxidizing agent, reducing agent, all that we will learn in the next class. All right. We'll continue in the next class. Ma'am, I'm stopping the class, ma'am.
Okay, sir. Thank you, sir.